Hello everyone, my name is Niels and welcome to this demo video of the Conditional Metric Explorer. With the Conditional Metric Explorer we want to solve the data ingestion validation problem. With this problem we assume that at the end of the day a system collects all of the data and dumps this into a database. If we do this for multiple days we actually get a historical sequence of data. With the data ingestion validation problem we want to validate whether a new and unseen batch of data is actually of good enough data quality. Up until now, this has always been done by using data unit tests based on column metrics. These metrics compute aggregate values on an entire column, such as the average value, the minimum value on numerical columns, or the average number of letters per tuple in a string column. But if we have a specific scenario where, for example, a single train always reports exactly 0 delay, this is an error because a train is never always exactly on time. There is some fluctuation, it might be a little bit early, it might be a little bit late. Using these column-based metrics, these will not change significantly enough, so these will not be able to detect the error. That is why we propose conditional metrics. These select a subset of the table and then compute a column-based metric on that. For example, we want to calculate something on the delay column based on something in the train column and only for train 1507. If we do this, we'll actually find this metric is 0 and we have indeed found the error. Now, using these conditional metrics, we can see that the train number here, train number 1507, that is something we call an entity. Each conditional is actually a unique entity. For this tool, we'll be using the following workflow. When a new batch of data enters the system uses the data unit test based on conditional metrics that we have already trained and modeled to validate this new batch. This will give us a set of failed unit tests, and the goal for these unit tests is to find a good explanation for all of the errors in the batch. Now, this is not as trivial as it seems, because these errors are often highly correlated, and with conditional metrics you often get a lot of errors. So that's why we'll be using the Conditional Metric Explorer to make more sense of these failed unit tests using user feedback. Now, how do we do this validation? Well, we generate an entity tuple graph out of all of the errors in the batch. This entity tuple graph is created by linking all of the entities from the failed conditional metrics to the tuples that they select in the batch. This will give us a graph on which we can run graph topology algorithms to analyze them and score each individual entity. The view here on the right is a graph that is actually contracted, so each of the green nodes are sets of tuples, unique sets of tuples. Using those graph topology algorithms, we can score each individual entity, and this is something we can use to filter out specific entities that are most likely to be the root cause of the error. So now that we have the validation and the failed unit tests, we want to use the Conditional Metric Explorer to manually explore these failed unit tests and find the root cause of the error. Okay, so now this is the interface of our tool. First, we can see our graph view here. We can see that there are 3 connected components in this graph. Each of these components probably describe a single error in the dataset, but many entities have flagged these 3 errors in this case. We'll start by analyzing this one in the middle here. Of this connected component with only a single entity, we can select this entity and then view the history of all of the conditional metrics that have failed for this entity. This history view immediately tells us the upper and lower bounds of the expected values, and we also see the current value here in green at the bottom, so this is clearly an outlier. This conditional metric tells us that we need to look for this delay column, so in this case I'll go to the Relation Explorer, only select the relevant columns, and then we can see that the delay of this train is indeed always 0 for the entire train number. So this probably means that the error for this train is indeed the delay, and we have found the error for this specific train. Now, the other 2 components are a bit larger, so these are more difficult to analyze. However, we have some tools for this. We can choose to ignore entities of an entire column. In this case, I have already verified that every entity in the 2 columns that I have selected here are fine. I've also verified that these 2 relationships, the entities of these relations, are also fine. So this reconstructs the graph with only the entities that we want to show now. Now we can select another train number and analyze this even further. However, there's also another tool available for us, and these are the scores of each entity. Every component has a set of scores that we can analyze. In this case, we see that for component 1, this train number is at the top. So according to our filtering metrics, this train number is the most likely explanation for the error. We can also see this for component 0. To make our life even simpler, what we can do is select the filtered view. This will only show the entities in the entity tuple view that have a very high score for each individual component. And this shows us only the 3 entities that have actually produced the error. I know this because we have inserted these errors manually for this demonstration, so these are actually all the correct entities.